Hello and welcome to Analysis Services 109, Attribute Relationships. This is the video you've been waiting for. I've talked a lot about it. Attribute relationships are incredibly important, and I'm going to present them to you in this video and hopefully help you understand why they are so important. In fact, after you create your dimensions and define your hierarchies, this is the next thing you should do. And it is extremely rare for cubes not to have any attribute relationships in them. So this is something that you're really going to want to do in almost every single dimension you create. So what are attribute relationships? I've mentioned them many times in previous videos, and it's important to understand what it is they do and how they work. So the first thing to understand is that attribute relationships simply tell the analysis services engine how attributes are related to each other. Now that sounds somewhat redundant. Attribute relationships tell the engine how attributes are related, but this is very important because without defining this, the engine has no way of knowing that two attributes are related. In Analysis Services 2000, it was assumed when you built a hierarchical structure, which was the only way you could do dimensions there, it assumed that they were already related. In 2005 and 2008, because you have attribute relationships, it cannot make that assumption. So you have to specifically tell the engine how these different attributes are related. Now by default, all attributes actually are related, but only to the key value, the key attribute for that particular dimension. So that's typically your lowest level of granularity. In a time dimension, it would be the day or the hour, the minute, the second, whatever your lowest level of granularity is. Same thing with product. Your lowest level of granularity is typically an individual product, a SKU, and so all your other attributes are related to the fact table through that key. It makes sense if you think about the star schema for a moment. You have the fact table, and they are tied, it is tied to the multiple dimension tables through the foreign key relationships. So that is the lowest level of granularity, and everything must run through that key value. And I'll show you a little bit more about this coming up in a few minutes. So what this means is that every query that you do, if you don't define attribute relationships, every query that you do must go to the lowest level of data in order to be resolved. Now, this is counter to what you might have been thinking about with a cube because of aggregations. If you have sales for an individual day for individual products, then you might say, well, it's easy to imagine the total by product for a month or a quarter or a year, or the total for product subcategories or product categories for a particular day or a month or a year. And this is true, but those aggregations cannot be created unless the engine understands, hey, days roll up into months, months roll up into quarters, quarters roll up into years. Same thing on the product side. Wow, a product belongs to a subcategory, and the subcategory belongs to a category. So without having that information, what you end up with is you have here, this is the fact table, this is the fact internet sales table, and I have individual products for a particular day, and in this case by customer as well. So product 346 on day 1 was sold to this customer, and then out to the right I have the other values. So what that means is, and here again 346 was sold on day 1, but just to a different customer. So in order to say what was the total sales for product 346 on day 1, well, I could just write a sum statement and it would run through all the records that have an order date key of 1. But now imagine that you needed a year total, and you needed the year total not just for one product but for all products. Well, that query might have to sum up millions or even billions of records. Whereas if you had proper aggregations built, and let's say that the cube had already calculated aggregations at the quarter level, and you asked for the yearly total, it would just have to add up 4 numbers. So this particular video is not about aggregations. There'll be one coming up in the near future on that. But it's important to understand that right now, without attribute relationships, every query is going down to this lowest level of detail in the fact table. Certainly, we want to prevent that from happening because with large data warehouses, with large cubes, there can be millions, billions of records in the fact table, and creating a high-level aggregate can take a very long time, even as fast as cubes are. Now, so why should you use attribute relationships? Well, I just gave you one very good reason, and that is because it greatly improves query performance. It allows the engine to understand how these things are related, so when I ask for a year total, if it has the quarters already calculated, it says, oh, I just have to add up 4 numbers. Even if it only has the months pre-calculated, it only has to add up 12 numbers. So attribute relationships can greatly increase query performance. They decrease the time, they improve that query performance. They can actually also improve the processing time on the dimension and the cube. The dimension, it helps it by loading it and actually storing it physically on disk better, and then the cube understands how these things are related, and it can build some aggregations off of other aggregations. So the whole process, both the processing and query performance, can be greatly increased, and you do get better storage of the data on disk. So if I told you there was one magic bullet that made your processing faster and made your queries faster, you'd think, well, I should certainly be doing that. And of course, that magic bullet is attribute relationships. Not that there aren't challenges with attribute relationships, there certainly are, and I'll show you some of those coming up here in just a moment. So given these benefits, again, I mentioned this before, once you define your dimension and build those hierarchies, this is the single most important thing that you can do. And it's important to understand that you need to define these correctly. You can actually very easily define them incorrectly, and you end up sometimes worse off than if you hadn't done them at all. So before I jump in and start doing the demo here, there are a couple of big differences between 2005 and 2008. I will show you both in this video. First of all, creating attribute relationships in 2005, the slide is sort of kind here. It says not particularly intuitive. I think it's backwards personally, and I think it's not intuitive at all. But I will show that to you and walk you through how I have to look at it. And I still make mistakes doing it. I've been doing this for a long time, and yet it's still easy to get it backwards. The good news is that in BI Dev Studio 2008, there's a graphical attribute relationship designer. This makes things much easier and makes it a lot easier to spot problems, circular references, and so on. So it's very useful, and I will show you that tool as well. In addition, and this is a little hard to explain, but I'll actually show it to you. Sometimes you can have a dimension created and define your attribute relationships, and the data doesn't match exactly what you think it should. 2005 will let you go ahead and process that. And then when you look at the data, it's all wrong. 2008 blocks that processing. It won't let you do it. And I'll show you in 2005, obviously, how to get around it. But I'll show you the proper way to do it in both 2005 and 2008. So, with that, let's jump into first look at attribute relationships. I'll start in 2005, but then I'll go into 2008 and show it to you in both environments. Here I am in Analysis Services, or BI Dev Studio 2005, and this is pretty much where I left off in the last video, but for those of you who haven't seen it, just couldn't wait and jumped right into attribute relationships, I have a very simple customer dimension. It's based on 2 tables, and from those 2 tables I have pulled the country, the state province, the city, and then the actual customers, what I've included in the customers hierarchy. Now I do have postal code over here. I could put that between city and customer, but it's fine the way it is. Just to point out, country, the country attribute here is the, I'll try to get this so you can see it, the country region code. but the name column is the English country region name. So it's the code underneath, but you'll see the name. In the same manner, the state province is the state province code, but the name is the state province name. The city is already a character, so there's no code and then the city. And then for dim customer, of course, it is the customer key of the key of the customer table, the primary key here, but the name column for it is the full name, which was something that was created in the DSV, so it's a name calculation, which just concatenates the first and last name. You see it here. So I have brought those over and put them into a hierarchy called customers. So country, state, province, city, customer. I also went ahead and grabbed a few other attributes, gender, marital status, yearly income, and put them in another hierarchy called demographics. Now, there are two main types of hierarchical structures. There's natural, and then there's the other kind. I've never heard a definitive answer for what the other kind is called. It's not unnatural, but it's sometimes called a reporting hierarchy, or simply a drill down hierarchy, or what have you. So basically the difference is a natural hierarchy has a natural structure to it. Years break down into quarters, quarters into months, months into days. Customers here break down from country to state, province to city to customer. That's natural. Gender to marital status to yearly income is not natural. It may be a way the business looks at the data, but it's not a natural hierarchy. It just may be some way they like to look at it. So in other words, a gender, male, female, does not necessarily break down into a particular marital status, whereas a state province does belong to a certain country. So that's the difference between these two. Now, you'll notice that both of these have a little warning indicator. And if I hover over that, the complaint is that attribute relationships do not exist. Okay, that's true. And I'm in 2005, so I want to define what those are. I need to tell the engine how these are related. Right now, if I expand dim customer, you'll notice that every attribute is tied to dim customer. So again, if I want the total by a country, it has to go down to the individual customer level, read every individual customer and add those up to get me this country value. Well, I don't want that. I want it to be able to go just to the state province level and retrieve that information for me. So at this point, I can create the attribute relationships. And again, in 2005, I think it's somewhat backwards. I'm sure there's a good reason for doing it this way. But you actually place the parent under the child. And so the way I like to say this is, I'll expand state province, and you see here an option for new attribute relationship. I say state province rolls up into country. So then I put country underneath that. So notice here that state province rolls up into country. Likewise, city rolls up into state province. And finally, of course, customers roll up into city. That's already defined for me. So if you look at this, notice that the warning indicator on the customers hierarchy is gone. That's because I have now defined relationships between all of these particular values. Now, let's keep this the way it is. I'll go ahead and save this, and then we'll come back to it. I'm not going to make any more changes to this. But I also want to show this to you in the time dimension. Notice that here in the time dimension, first of all, I have a horrible name for the hierarchy. This was done by the wizard for me. So I'm just going to call this calendar. And I'll quickly rename these to just year and quarter and month and day. So here I have a calendar, and again, notice that even though the wizard created this for me and I set up the time dimension and told it what attributes were tied to different levels, it doesn't create the attribute relationships for me. I still have that warning. Well, let's leave it this way for now, not create those, and then I'll show you some other things about this. So we have the time dimension with a hierarchy, no attribute relationships, but we have defined attribute relationships in the customer dimension. So at this point, I'll simply deploy this and show you several things about this. So once processing is complete, I can go and examine what this looks like. And I can just use the dimension browser here. And notice I'm looking at the calendar hierarchy. Of course, there is an all level. I did not turn that off. And if I expand this, I see 2005, and I can expand this and I see quarters 3 and 4. Now that's the only data that I have, so that is correct. And I can expand that. Of course, I see months 7, 8, 9, months 10, 11, and 12 under the fourth quarter. If I expand 2006 and 2007, I do see quarters 1 through 4 for each of those. 2008, I only have the first 3 quarters. So this is the data, and it looks correct. And in fact, it is. I can go and browse this. But remember, I haven't defined any attribute relationships yet. So it builds this structure, and it works well. I can drill down, and the data is correct. But I'm not getting the benefits of the faster processing, the faster querying. It doesn't know how these are related. So to get a total for 2005, again, it has to go all the way down to the day level and read all those records. Now, for the customer dimension, again, the customers hierarchy, I have here all customers, and if I expand that, I have the countries. Within the countries, I have the state provinces, and then of course I have the cities, and within the cities, I have the individual customers. Now, all of this looks good so far. In reality, there's a problem here, and I'll show you in a moment how to figure that out. Actually, it's kind of difficult in 2005, but I'll show it to you in 2008, then we'll come back and examine what in the world is going on in 2005 that lets this happen. Well, before I do that, you'll actually see the problem very clearly when I come back to the time dimension. So I'll come back to the time dimension, and everything looks great. Everything's working well. So let's go ahead and define those attribute relationships. Again, everything is related to the time key. And the way to look at this is quarters roll up into years. So year will go below quarter. And months roll up into quarters. And then, of course, the day, the time key here, rolls up into months. And actually, day is not the time key. I use the full date alternate key. So the date rolls up into the month. And once I do that, the exclamation mark goes away, tells me I have created these attribute relationships, and I will just click the process button to tell it to go ahead and reprocess this particular dimension. So now it's going to perform the process on dim time, and the process has completed. And I'll go ahead and close this, and now I'll return to the browser, and of course I have to reconnect. And when I do, notice the data suddenly doesn't look so good. There's no way to expand 2008, and yet before I had 3 quarters under it. If I expand 2005, I do have quarters 3 and 4. That looks good. 2006 only has quarter 2. 2007 only has quarter 1. So I just told you all these great benefits about attribute relationships, and I totally broke my dimension by using them. Well, fortunately, there's a really easy way to fix this, and there's a very good reason this is occurring. And after I show you how to do all this in 2008, we'll come back and fix that. Okay, jumping into BI Dev Studio for 2008 for a moment, I have several attributes left over from previous videos that aren't correct, so I'll get rid of the English country region name, and I'll get rid of the state province name. City is correct, and of course the customer key is fine. So what I actually want to do here is get the country region code and the state province code. For country region code, I'll rename that simply to country to make life a little bit easier. But for this, I I have the code, but the name that I want to show is the actual English country region name. For state province code, again, I'll rename that simply to state province. And its name column I will set to the state province name. I will now create the hierarchy. I'll start again with the country. And I will then move, little pause there while it woke up, from country to state province to city, and then again to the customer. Now the customer key is already set up so that the name column is the full name, just as it was in 2005. I'll rename this to customers. And again, I have the warning here that the attribute relationships do not exist. Unlike what you saw in 2005, in 2008 I have a tab up here for attribute relationships. And this is showing me that right now state province and country and geography key are tied to the customer, and then there is city. So it looks a little strange because I have two tables in this, but remember that geography key is an attribute in the customer table. And so what I need to do is just tell this how these pieces fit together. Remember that the customer rolls up into the city. The city then rolls up into the country. So I'll take country and drop it on city. Whoops, wrong direction. Sorry, I'll take city. City rolls up into country and drop it this way. Notice now that the geography key, I go from customer to city through geography key and then over into the country. And the country, whoops, sorry, that's not right. You know, so much for live demos. Okay, the city rolls up into a state province, and then the state province rolls up into a country. So now I have this nice line here from the customer through the geography key to the city, to the state, to the country. And those are now defined for me. And if I return to the dimension structure, you'll notice that the warning indicator is gone. Now, at this point, I could actually attempt to process, but I would get an error. And don't worry too much about that at the moment. I'll show that to you and prove it to you in just a moment. And that's one of the things, again, that 2008 will prevent me from doing that 2005 just let me do. Same thing with the time dimension. So let's open up dim time. I need to add the year. So it was calendar year, calendar quarter, and then I actually had the month number of the year, which is fine, and then I had the full date alternate key. So at this point, I will create a new hierarchy from year to quarter to month to day, and I will rename these quickly to simply year, quarter, month, and day, and I will name this calendar, as I did in 2005. Again, I'm getting a warning. It's just that attribute relationships are not set. Now remember, if I go ahead and process now, things are fine. I haven't created any attribute relationships. It will create properly. But remember in 2005, after I created the attribute relationships and I then processed, I only had one quarter under 2007 and one under 2006 and nothing under 2008. So let me go ahead and create the attribute relationships here. And again, I'm going from time key the lowest. Full date alternate key is the day. Days roll up into months. Months roll up into quarters, and quarters roll up into years. I can return here. Sure enough, the indicator's gone. Now, if I attempt to deploy this, I've made changes to both time and customer and created attribute relationships. And somewhere in this process, I'm going to get an error. And I'll show you what that is. I may get it in time here, I may get it in customer, but actually there are errors in both, and I'll explain what's going on. So again, this is simply a case of where 2008 is preventing me from stabbing myself or shooting myself in the foot, where 2005 actually let me do it. Okay, up pop a list of errors, and some of them are just warnings. Don't have visible attribute hierarchies. If you've put the attributes in a user-defined hierarchy, that's fine. I did that in 2005. But if I scroll down here, here are the actual errors. And the error that I'm most interested in is right here. There's a duplicate attribute key in the geography table. There's a city named Augsburg, and it's a duplicate. Well, that's actually what we have with a lot of these. So let's go back to the slides, explain what's going on, and I'll come back and I'll fix it in both 2005 and 2008. And there are a couple of ways of doing that in each one. There's the right way, and there's a way in 2005 that it would have caught this same error, and I'll show you how to do that as well. So back in the slides, let's talk about the key columns and name columns. These are two properties of an attribute, and they are extremely important. The key columns property defines what it takes to make that attribute unique. In the basic processing that I did before, I think I mentioned that every attribute that you have in a dimension, when you process it, there is a select distinct query that goes to the dimension table for that attribute. So if you think about it, in the time dimension that I had before, I had month number of year. So there were numbers 1 through 12. And that's all that was in that attribute. So if you do a select distinct, you will get 12 values back, 1 through 12. Well, that's great, except that every year has a month 1 and a month 2 and a month 3. So really, I want to get back the distinct values that make it unique. And what makes it unique is the year in which that month resides. So there's a month 1 in the year 2005 and a month 1 in the year 2006 and so forth. So you'll go into the key columns and specify what it takes to make that particular attribute unique. Now, if you set multiple values in the key columns, if you set multiple columns there, in other words, the year and the month, or the year and the quarter, then you must set the name columns property, because now it doesn't know what to display. It says, well, gee, I have 2 columns here, and so you just have to tell it one of those 2 columns, or you could actually pick a third if you wanted, but it's typically one of those 2. So what does this look like? Well, let's go back first into 2005 and fix that time dimension problem. Because as you can imagine, the users are not going to be happy browsing with that. Before I get there, though, the other piece I want to talk about are some properties on the attribute relationship itself. So you've seen properties on the attributes, you've seen properties on the levels and the hierarchies, and on the hierarchy itself, and on the dimension itself. Well, the attribute relationship has properties as well. Fortunately, not very many, and there are only 2 I'll mention here. One is the relationship type, and it only has 2 possible values, flexible and rigid. The other is cardinality, and it also only has 2 types, 2 values. But on the relationship type, flexible is the default, and it says that this relationship can change over time, whereas rigid says the relationship should not change over time. So take, for example, a person living in a city. Is that flexible? Absolutely. A person can move from one city to another. On the other hand, should a city move from one state to another? Okay, yes, technically that has happened before, but in general, no, that shouldn't happen. A state or a province should not move from one country to another. So those would be rigid relationships. This typically only comes into play when you are loading data incrementally. You're simply loading new data as it comes in. And if you've set it to rigid, let's say you have the relationship between city and state province, and you've set that to rigid, and all of a sudden here comes that city showing up under a new state province, it's going to throw an error. If you have it set to flexible, it just says, oh, okay, that's fine, they've moved, and it doesn't worry about it. Now, typically that's used for incremental processing. However, when we do a full load, if it's set to flexible in 2005, it lets it do exactly what you saw with the time dimension. However, had I set that to rigid before doing the full processing, then it would have choked on that and given me an error. So if you can set something to rigid, you should. And time is a great example. The first quarter of 2006 should never move out of the year 2006. Okay, I'm not talking about fiscal versus calendar, just the actual dates. So I'll go in and change some of those relationships from flexible to rigid and let you see that 2005, oh, now it does fail. And then we will update the key columns and name columns mentioned on the previous slide. The other attribute relationship property is just cardinality. Many is the default, just indicates a many-to-one relationship from the lower level to the higher level. And then the other option is a one-to-one relationship. So again, I'm going to jump into 2005 first, talk about the key columns and name columns and the rigid and flexible relationship types. Then I'll go and do the same thing in 2008. All those things work the same in 2005 versus 2008. Back in 2005, you can see the very messed up time dimension. Now, it let me process it this way, and think about again what it did. It did a select distinct query on quarters. Well, there are only 4 possible quarter values because I'm using the numbers, and I used 1, 2, 3, and 4. So because the attribute relationship is flexible, it said, okay, well, here's a quarter 1 in the year 2006, and here's one in 2007, here's one in 2008, and somewhere along the lines it makes the decision, okay, 2007, that's where it'll go. Somewhere along the line it made the decision that the second quarter would be under 2006 and the third and fourth would be under 2005. Obviously, that's not going to be very useful in browsing for end users. So back in the dimension structure, again, a couple of options here, and I will really fix this in a moment, but I could have at least prevented that bad processing by setting the properties on my attribute relationships. So should a quarter move from one year to another? Well, no. They do in this case because I only have the numbers 1 through 4, but the first quarter of 2007 should never move to a different year. So I'm going to set that to rigid, and in fact I'll set all these to rigid. And later in the video on aggregations, we'll talk more about this. It's actually, you get better aggregations if you have rigid relationship types. You don't always. You can't always. There are true cases where obviously flexible is what you need. But I've made these changes, so let me go and attempt to process this, and now it will fail because it will see, oh, wait a minute, a particular quarter moved from one year to another, or it might see it for a month, or well, I shouldn't see it for a day here, but it may see it for a month or a quarter. So in a moment, I'll get an error to come up with this particular process. Now, fortunately, it didn't take long, and it needs to transfer some information. And unfortunately, I have a feature in this particular virtual machine where the trace doesn't always come back, so I'll click stop here. But notice here's the error that I'm actually interested in. An error occurred. The calendar quarter attribute well, basically it doesn't finish it up. That's where the error is, though, and that's not surprising. So how do I fix this? Well, remember the key column and name column properties. So what I want to do under the calendar quarter, in order to make a quarter unique, since it's just a number 1 through 4, under this key columns property, it's just calendar quarter. That's not enough to make it unique. So I click the ellipses next to it, and it brings up this data item collection editor dialog, and notice that the only member right now is the calendar quarter. Well, if I click Add to this, and over here in the source, I say what I want is a column binding, and I want the actual calendar year, and then you do want to put these in the correct order, year to quarter. And so now what this says is that the year plus the quarter make it unique, and that is correct. And the name column is already set to calendar quarter, so that's fine. I will then do the same thing for the month. It's just the month number of year, and I will open this up and I add again what makes it unique, not the quarter, but the year. So the calendar year combined with the month number makes that unique as well. And again, the name column is month number. Now I could drop this down and choose new and choose, for example, the English month name. Doesn't really matter, either one will work. I just have to set that name column. So now, having done that, let's process this again. And it will deploy to the server and then allow me to process. And it should process correctly now. So now I'm running the process and it's already done and it has succeeded. So I will stop this and close it. And if I go back to the browser, remember, need to reconnect. And now we're back to normal. 2006, 1 through 4, 2007, 1 through 4, 2008 has its 3 quarters back, 2005 just has 3 and 4, which it started with. All is correct. So you might say, well, okay, that's great. Now, you said there was something wrong with customer. Well, again, because I have flexible attribute relationships between these, I don't see what the problem is here. If I come back to this and I say, okay, a city should not move from one state province to another, I can come in here and make this rigid. And I can also say that a state province should not move from one country to another, so I'll make that rigid. But now a customer can move from one city to another, so yeah, I need to leave that relationship flexible. So now, let me process this. And this isn't going to work. This is going to show you what the problem is. I'll jump over into 2008 where it's much more obvious, and we'll take a look at it there. So you notice it failed, and you saw it in 2008 before. It told us what the error was. So let's leave this as it is. I'll go to 2008, I'll do these same things over there, and then we'll come back and look at what the problem happens to be with this geography, and then how to fix that. I'm back in 2008, and remember that in 2005 it let me process the time dimension after adding attribute relationships, but it was all messed up. So in 2008, the good news was it wouldn't let me deploy that way. So let me come in here, and for calendar quarter, I need to do the same thing here I did in 2005. I need to say that a calendar quarter, now this dialog looks a little bit different, it's a little bit improved in my opinion. I have calendar quarter, I also need calendar year, so I'll bring that over. And again, they need to go in the right order, and I'll click OK. And then notice almost immediately it gets a red squiggly line under it. It says the name column should be defined. I mentioned that in the slides. If you tried to process here, it wouldn't work. So now the name column, I will go ahead, this is the quarter, so I'll just choose calendar quarter. And then the same thing with the month number of year, I need to include the year with that, put them in the correct order. And again, for the name column, I can choose English month name or month number of year. It doesn't matter here, I'll choose month number of year here just to make it slightly different from the 2005 example. Now if I go to process this dimension at this point, it's going to send to the server, And if I go to, my deploy actually failed. Oh, there we go. Here we go. Now I'm going to process full on this. Now I'm processing just dim time. I still have a problem, or will soon, in geography, but this has completed, and now I should be able to browse this, and it should work properly just like it did in 2005. Now these values are slightly different. The years are older, but it's the same. 2001 maps to 5, and 2002 to 2006, and so forth. But you see 3 and 4, and then the first 4, and then all 4 quarters in the next 2 years, and the first 3 quarters in the last year. So this has worked. Let me go to customer now, and if I attempt to process the customer dimension, I get this failure, and I pointed this out before. It's complaining about a city called Augsburg not being unique. Well, you would think that cities would be unique according to a state province. However, in this particular data, that's not the case. I'm going to jump back into 2005 for just a moment, because it's the same database, the only difference is in the years, and I'm going to open up an incredibly complex query and show you what this data happens to look like. Okay, apparently not. I'll just create the query from scratch here, which is fine. So by way of example, of course I'm going to go into AdventureWorks DW. I'm going to do a select, and yes, I know select star is evil, but select star from not fact internet sales, from dim geography, where city equals, and I'm going to choose Berlin. I know the error that we were getting was Augsburg, but Berlin will show you the same thing. Notice here that in this particular data set, I have a city named Berlin. It is in Germany in every case, but I have it listed in a number of different state provinces: Brandenburg, Hessen, Hamburg, and a couple of others. So I, in this example, have cities that are not unique within state provinces. Well, you know how to fix that, because we just did it with time before. So I'll jump back into 2008 for a moment, and I will say, okay, for a city, what makes it unique is the city and the state province. So I have to come here and choose the state province code, move it over, move that up above the city, click OK, and of course the name column I want here is just the city. So now at this point, I should be able to deploy this, and now I should be able to process the customer dimension and get around those errors that I had before. Sure enough, it finishes processing. And if I go to browse this, you will actually see, if I go to Germany, I can choose, for example, Hamburg, and there is Berlin with people listed under it. And then I can also go to Hessen, and there again is Berlin with different people listed under it. Now, is this correct? Well, this maps to the data that I have in my dimension table. My dimension table may be incorrect, it may be correct. This is something you would have to examine. But here's the key. 2008 would not let me process this until I fixed that. Okay, I did set the, well, if I'd set the attribute relationship to rigid in 2005, it wouldn't let me do it. But otherwise in 2005, with a flexible relationship, it would let me do it. 2008 wouldn't let me do it, period. So that's what I mentioned before with 2005 and 8. 2008 will keep you from doing certain things that 2005 will let you do that you may not want to do. So this is an important point. In 2005, I was able to create that customer's dimension, And if I go and look at Germany, and I look under Hamburg, Berlin's not there. We'll look under Hessen. No, it's not there either. I don't know where it is. It's hiding very well somewhere. There it is under Brandenburg. So this, I didn't get any errors processing this. I have attribute relationships defined. But in 2005, it's wrong, at least according to the data that I have in my dimension table. So this is why it's very important whenever you can to create those relationships as rigid versus flexible. Okay? And it is also extremely important that you understand that your data matches, and that it matches what's in the dimension table, and that what you've processed actually relates and is correct according to what's in your dimension table. Now, I created those attribute relationships, or I didn't create them, I made them rigid here. And if I go and do a process full in 2005, and let me go ahead and stop this and jump into the browser. And sorry about that. If I do a process full, it will work. It will just take the last one in. If I did a process update, though, that would say, okay, new data coming in has changed from previous data. That's going to fail. So set those to rigid, but make sure that you also set the key values correctly. So for city, I have that same problem. I showed you before in 2005 just what that happens to look like, that Berlin does fall under multiple state provinces. So I'll come in here, and for geography, I will say that the city is only unique inside of a state province code city combination, and of course I will then set it to the name of the city is what is displayed. And now if I reprocess this, and in this case, because I've changed the structure around a little bit, it needs to do some additional work. And therefore the process will be full, but I'll go ahead and run this. And of course it has succeeded. And if I go and browse now and reconnect, you will notice that Berlin does show up in multiple state provinces, just as it does in our actual dimension table. And unlike just a moment ago, if I return here and reprocess and choose a process update, it will succeed, which again, a moment ago it was failing. But now that I have correctly set the key columns, it works fine. Now there's one more thing that I want to point out to you. And if you come from the 2000 world, you were probably used to this concept of member properties, where basically you might have something in the dimension table, such as an email address, that tied to a customer, but it wasn't part of the hierarchy. You didn't drill from customer to email address or from email address to customer. It was just additional information about that customer. Well, you could have information about any level, not just the customer, but the city or the state or what have you. And you may want to include that in the dimension, but you might not in 2005 or 2008 want to make it its own attribute. In other words, if you had the email address, would you want the person to be able to analyze the data by that? Would you want a user to be able to drag that over and treat it like its own hierarchy? Well, typically not on something like an email address. So there's no direct concept of member properties here, but it's easy to create. And I'll show you an example of how to do that here. What I will do is I will take in the customer let me scroll down here. I have the phone. You typically would not want to analyze sales by phone number unless you're a telemarketing firm, perhaps. So I'm just going to bring phone over and drop it as an attribute. Notice two things happen with phone. First of all, it is added as an attribute, which is not surprising, but it's also added as there's an attribute relationship adding to dim customer. Now in this case, that is the correct place for it. But right now, of course, it is an attribute, so if I publish this, someone could drag it over and analyze by phone. Now I could, for the phone attribute, I could come over here and look at those properties. I could say attribute hierarchy enabled is false, but there's actually a better way of doing this. If I don't want people to analyze by it, then I can actually say attribute hierarchy visible is equal to false. And this actually makes processing more efficient for it. It doesn't bother, or I'm sorry, not visible false. Actually, doesn't matter here. But I actually do want the attribute hierarchy enabled to false. I don't want it to be its own hierarchy. So notice that it gets the little blue boxes turn gray, so it's grayed out. So it won't show up. In fact, I couldn't even bring it over and put it in a hierarchy. I get an error when that happens. So I can't even use it in that sense. What this does is it doesn't use any, well, it does use some storage, but it doesn't include a lot of storage and optimizing for it and so forth like it does these other attributes. So what I can do simply by taking an attribute and setting its attribute hierarchy enabled to false and then tying it with an attribute relationship to the proper value, it becomes a member property for that particular value. Now, how do you see that? Well, let me deploy this project and process it, and I'll take you into the browser and then show you what that looks like. And a lot of it depends on your client tool. But this is another use for these attribute relationships, is they are what allow you to have the equivalent of member properties from the old 2000 days. And again, I'll show you in just a moment what this looks like in the browser. So now that the processing has complete, I'll go to the cube and open the browser. So now in the browser, if I open up the customer, you'll notice that I can expand this, and nowhere do I see phone, which is okay. I'll bring my customers over, and I can choose a country to expand, and then a state, province, and then a city, and get down to the individual customers. And if I hover over one of these, by default I just see the name of the customer. But in this particular browser, if I right click and say show properties in screen tips and then say show all properties in screen tips, now if I hover over one of these customers, I see some additional information about them. So number of cars owned, that happens to be an attribute that I've added, but you see down here the phone, and of course if I move to a different one, I'll get a pop-up with a different phone number. So right now, any attribute that is tied to this key value, I'm seeing the value for it in this pop-up. And this works in ProClarity and in other tools as well. So it just depends on the client tool to show you that. But again, I can't analyze by phone number. I can't drag it over here and drop it, and yet I'm able to see it as a member property. And in fact, ProClarity can do some pretty interesting things. It can show the member property instead of the default value, and you can search on these member properties, which makes it very powerful. So you could, for example, have a member property of the yearly income and then search for everyone in a particular range and find all those people regardless of what country or state, province, or city they happen to be in. So, back to the slides for the summary. You've seen in a rather lengthy video attribute relationships and how you tell the engine, hey, guess what? These dates roll up into the months, and these months roll up into quarters, and these quarters roll up into years. When we start building aggregations, that's really important, again, because it now knows that when you ask a question, instead of having to go to that lowest level of detail, it can simply take a higher level aggregation and sum it up if it needs to, if it hasn't already calculated it. And it makes it much more efficient. So queries are faster. Processing actually occurs faster, again, because when it's building these aggregations, it can build the lower level ones first and then base higher levels on that lower level of detail. Anytime you can, build attribute relationships. Now, back in the 2005 example, for customer, I have another hierarchy here, and I did not build attribute relationships for it. It doesn't make sense. Gender doesn't break down into marital status or vice versa. Marital status and yearly income are not related. So that one's for user convenience, but I can't really add attribute relationships to that and have anything valid. So you won't always be able to, but anytime you can, you should. Also, anytime you can set the relationship type to rigid, you should, because that will avoid some of the processing problems that you saw in 2005. It lets you process the time dimension, but it was all messed up. Okay. Same thing with geography, and that was very hard to tell that geography was messed up. Fortunately, 2008 prevented you from making some of those same mistakes. It actually gave warnings, and that makes 2008 a lot more powerful in that sense. Also, when you're doing this, don't forget to set those key columns whenever necessary, and that was the problem with both time and geography, as it turned out. Those values were not unique by themselves, so you had to go in and tell it what else made it unique. Also, don't forget that attribute relationships are what you can use to basically create member properties in the old 2000 sense. So, attribute relationships, attribute relationships, attribute relationships. Extremely important concept. Thank you.